guys, welcome to Pure Maths 1, Lesson 2. We're talking about trigonometric identities. I suggest really strongly that you have a look at page 92 and look at the information and the examples on page 93 as well. Before you watch this video, it will help make sense of what we're doing. The key idea from this lesson is to be able to use these two identities. Tan theta is equal to sine theta over cosine theta, and sine squared theta plus cosine squared theta equals 1. And of course these can be rearranged. So for example, you could rearrange this so that you have, for example, sine squared theta equals 1 minus cosine squared theta. We do that by moving this across to the other side. And of course the other way would be to move the sine across. Cosine squared theta will equal 1 minus sine squared theta. So just be aware of those as well. Okay, so we're going to use some of these identities to solve some equations or prove some things. I've selected a couple that I'm going to do with you. I would like you to try most of the exercise, I guess would be really helpful. If you get stuck, I have worked examples for pretty much everything in this exercise, and I can send those to you as usual, as I've mentioned in the emails. Please send your working, how you've attempted it, so I might be able to clear up some misconceptions in your working or misunderstandings that you've got if I see that. Okay, so I've decided to do a few. I think we'll start off with something like number 1. We are trying to express 4 cosine squared x minus sine x squared x in terms of cosine x. So here's this is question 1. 4 cosine squared x minus sine squared x, and we're trying to put this into, express this as cosine. So using our identity here, 4 cosine squared x minus, and we can say that sine squared x is equal to 1 take away cosine squared x. Using this identity here, and then if we simplify that, that's going to be, well, the minus 1, that's easy enough, minus cosine x, that's a positive cosine squared x, so we're going to end up with a total of 5 cosine squared x minus 1, and that's question 1 done and dusted. Okay, let's take a look at something like 3b. Here we have, we're trying to simplify, so I'll start up here. 3b. We're given this equation, 1 plus sine theta plus cosine squared theta over 1 plus sine theta. Okay, so that's our question, and we're trying to simplify it. Okay, so what I'm going to do is I'm going to make all of this have the same denominator. Okay, so we're going to multiply all of this by 1 plus sine theta. So I'm going to get 1 plus sine theta squared, because I'm timesing this whole thing by the denominator here, plus cosine squared theta all over 1 plus sine theta. Pause the video there if you're not quite sure what I've done. Basically, I'm trying to get this part of the equation to have the same denominator. Okay, so now I'm going to expand this bracket here. So I might have 1 plus 2 sine theta plus sine squared theta plus cosine squared theta all over 1 plus sine theta. Okay, now we know that sine squared theta plus cosine squared theta is equal to 1. So we're going to have 1 plus 2 sine theta plus 1. So that's that bit there, is the plus 1, all over 1 plus sine theta. So far so good. The next line is going to read, well, we gather our like terms, so we're going to have 2 plus 2 sine theta, and that is going to be over 1 plus sine theta. Now this is getting exciting. Hopefully you can see we can factorize the top by pulling out a 2. Thus, and cancel-y, we are left with 2 as our final answer. So we've simplified that there. Okay, I'm going to try a couple more. Don't want to make this video too long. Let's have a look. What have we got here? Okay, let's look at number 5. We're trying to prove the identity that cosine to the power of 5 theta, or cosine theta to the power of 5, is equal to cosine theta minus sine squared theta cosine theta plus cosine theta sine to the 4 theta. So I suggest you have a look at that question just briefly. Have a look in your textbook. So this is number 5A. Okay, here we go. I'll work these identities out. And we're trying to prove that that is equal to the right-hand side of the equation. Now, what I'm going to do here is I'm going to split up my cosine to the power of 5 theta. So I'm going to go cosine squared theta times cosine squared theta times cosine theta. And then, at that point, I'm going to replace them with some sine squared thetas, because you can see, if you look at the right-hand side of the equation that we're trying to prove, we've got to have a sine theta to the power of 4. So the only way we can do that is by replacing these guys with 1 minus sine squared theta, using your identity. So look at the identity again. Sine squared theta plus cosine squared theta is equal to 1. So therefore this here is equal to 1 minus sine squared theta. So that is this, and then we're going to have another one of those brackets here, and then we're going to have this one here. That's a theta. And what we're going to do now is we're going to expand these brackets. So we could use FOIL 1. We're going to end up with 2 sine squared thetas, and then we're going to end up with a sine to the power, sine to the 4th theta. Now this is all in brackets, and it's all going to be times by cosine theta. And hopefully now you can see that we're actually going to get what we need. This times this, so we've got our cosine theta. I think that's the first term in the textbook. Then we're going to times this by this, so it's going to be minus 2 cosine theta sine squared theta. And this one will be cosine theta sine theta to the power of 4. Use my easy writing. So that's how we do that one. Let me try maybe one more. Let's have a look at, say, number 8a. We're going to try and prove that tan theta is equal to the square root of sine squared theta over 1 minus sine squared theta. So my first step is going to be, okay, I know that tan theta, using my identity, tan theta is equal to sine theta over cosine theta. I hope everyone is okay at that point. And given that that is the case, we know that that tan theta is going to be equal to the square root of sine squared theta cosine squared theta. Does that make sense? So the square root of this is the same as the square root of the top divided by square root of the bottom, which is that. Okay, so that's where we're at so far. Now, if I look at what I'm trying to prove here, I need to have a 1 minus sine squared theta on the bottom. I'm okay on the top here, so I'm just going to use my identity to change this cosine squared theta into 1 minus sine squared theta. I hope this has been helpful. Yes, I think this will be a challenge of an exercise for you, but I hope that you have a go at as many as you can. If you get stuck, make sure you email me because I will be able to send you through some worked examples. Good luck.